Octonitrocubane, or ONC, is the most powerful explosive known to man, even more powerful than the common military explosive, HMX. In this lab, we will determine the heat of combustion for both octonitrocubane and HMX to prove that octonitrocubane is more powerful than HMX. One of the reasons why ONC is so powerful is due to the strain that each carbon atom has. Normally, a carbon atom wants to form bond with bond angles of 109 degrees, but in octonitrocubane, it forms this cubane which allow for 90-degree carbon bond angles. This causes very energetic decombustion, which is one of the main factors that determines the power of an explosive.
We first started investigating octonitrocubane using NuChem, but due to the length of time that it took to complete a job due to the complexity of the structure, we transitioned to using a MOPAC engine on GabEdit. Presented before you is the octonitrocubane molecule in the builder of GabEdit. Notice the 90-degree angle strain on the carbons, which is one of the main reasons why it's such a strong explosive. We then took this molecule and ran an equilibrium structure search in order to find the heat of formation. We also used an equilibrium structure search on carbon dioxide and nitrogen gas, which is what this reactant forms when combusted, in order to find the overall enthalpy of formation.
The reaction of combustion of ONC is seen here, where you have ONC, which combusts into 8 carbon dioxide and 4 nitrogen molecules. After we ran MOPAC engines on each 3 of these molecules, we found that a heat of formation for ONC was 707.17 kilojoules per mole. For 1 carbon dioxide molecule, it was negative 354.85 kilojoules per mole. And for 1 nitrogen molecule, it was 169.74 kilojoules per mole.
The other molecule of interest, which is HMX, was also analyzed using a MOPAC engine on GabEdit. Before you is the HMX molecule in the builder of GabEdit. We ran an equilibrium structure search in order to find the enthalpy of formation of HMX. We also ran equilibrium structure searches on carbon monoxide, H2O, and nitrogen gas, which are the 3 products that form from the combustion of this reactant.
The combustion reaction for HMX is seen here, where HMX combusts into carbon monoxide, water, and nitrogen. After running a MOPAC engine for HMX, carbon monoxide, water, and nitrogen, we found that the heat of formation for HMX was negative 70.14044 kilojoules per mole. For 1 molecule of carbon monoxide, the heat of formation was negative 57.39404. For water, negative 227.21734. And for nitrogen, 169.7402 kilojoules per mole.
In conclusion, the final heat of reaction for HMX using Hess's law and products minus reactants was negative 389.346 kilojoules per mole. This is for the combustion of HMX. For the combustion of octonitrocubane, the final heat of reaction was negative 2,867.04 kilojoules per mole. The conversion to kilojoules per gram are presented directly below. This presents a ratio of 1 to 4.698 when comparing HMX to OMC, which proves that octonitrocubane is much stronger than HMX. Brought to you by the PChem Warriors. And remember, an operator must always operate on a function.